The next thing we're going to look at is the chain rule. You can see the definition of it here. If you have your y equals your composite function there, then the derivative is going to be defined as following. And then our next rule is going to be our power rule for functions. So if we had y equals u to the n, then we would take the derivative of that, which is n u to the n minus 1 times the derivative of the u. Alright, so we have two new rules that we're going to be working with, and we're going to work through some examples. We'll spend the rest of our time working through some examples using these two. Okay, so we have our first example is our f of x is equal to 3x squared minus 1 to the 4th power. Okay, so here we see that this is not just an x, so we would take 4 and multiply that out, so we'll have 4. If this is our u, we have this, which is just going to be 3x squared minus 1 to the n minus 1 power, so what would we get there? You said a 3. Now, because this is a u, we have to take the derivative of that. So let me represent it this first couple of times. All right. So I just bring this first term down, and then let's evaluate the derivative in this next step. What is the derivative of the term? What is the derivative of this? Just 6x. Good. Now let's just algebraically simplify that a little bit to get f prime of x is equal to, let's do 6 times 4 is 24x times what we have in our parentheses. Okay. Let's look at another one. So if my original function is 1 over x squared plus 3x minus 1. Alright, as of now, this technically isn't one of our new rules, but what can I use at this point? Quotient rule, low d high minus high d low over the square of what's below. But also, what else can I do? Algebraically, remember, what if I have 1 over x to the 4th? What would I ask you to do to simplify that? Bring it to x to the negative 4. So how else could I rewrite this f of x function if we wanted to just be able to apply one of today's rules to our yeah, so we'll take this entire rewrite as x squared plus 3x minus 1 and raise it to the what? Negative 1 power. Okay, that's just to be able to apply the rules that we're working with today, but you'll have the freedom to algebraically manipulate things, use trig functions, any kind of, or our natural log properties to use our derivative rules. Okay, so let's work with that. Now we have what? Negative 1. So the derivative is going to be, we pull this negative 1 front, so negative 1. Our parenthesis, this represents our u, so x squared plus 3x minus 1 to the what power? Negative 1 minus 1, good, to the negative 2 power. Now, because this is a u, we also have to take the derivative of the parenthesis as well. So alright, so next step is let's just evaluate this portion and then simplify algebraically. I'm just going to leave this alone for now. What is our derivative there? 2x, what, plus 3, and then a 0, so we just get 2x plus 3. Let's keep that in the denominator. Let's keep this in the numerator and move this to the denominator. So have parenthesis 2x plus 3, and then we're just going to move this term down to the denominator. X squared plus 3x minus 1 squared. Okay. Okay, so we have one of these, and we've done this before. What's your first suggestion? Rewrite algebraically, right? So let's rewrite this as 3 minus 2x to the 1/2 power. Okay, well now we can apply our rules. So we're going to get, taking the derivative of this, we would get y prom is equal to 1/2 to the what power? Minus 1, so it would be to the negative 1/2 power good times the derivative of that. Okay, our next step is we're just going to take some time to calculate our derivative. There. And what's it going to be? Negative 2, good. What about that negative 2 and this 2? They're going to cancel. So actually, let me carefully put my y prom. So when they cancel, we'll simplify this. We're just going to have y prom is equal to negative 1, and I'm going to go ahead and bring this down. So 3 minus 2x to the positive 1/2 power. How else could I rewrite that? With the radical, yeah. Okay. Be comfortable rewriting with the exponents or radicals. All right. 4 is fairly similar to some of the previous ones, other than we have this negative 3 out front, but I'm going to let you go ahead and pause it. Try this one on your own and then check your answer and see if you can do it. Okay, we're just going to leave this over here. We work with taking the derivative of this term, which is represented in red. Then the next step, we worry about derivative of this, which is in blue. So the derivative of the blue term is just negative 9. Now here, negative 3 times a negative 9 is a positive 27 over 4. Then we have just this term. Algebraically, we can move this to the denominator, and it's going to be the 4th root of 2 minus 9x to the 3rd power. So in some cases, if we just stop here with the derivative, that's fine, but be able to transition either answer right there. Okay, we have some options here. You could use quotient rule, and we'll also have power rule within that. So, or our chain rule right there. So let's go with, let's rewrite this algebraically so that we can use our rules for today. So that's just going to give us what? Negative 4 x plus 2 to the negative 2 power. Okay, so rewrite that, work with our properties today, and solve this one. Okay, so negative 2 times negative 4 is positive 8. X plus 2 to the negative 3rd power. The derivative of the parenthesis for our u term, which is just 1. And this just simplifies. If we move the negative exponent to the denominator, we'll finish with that. Okay, f of x, x over 2 minus 1 to the negative 10 power. Okay, so check your work. We're just going to get negative 10, 1/2 x minus 1 to the negative 11 times the derivative of our parenthesis. The derivative here is just going to be 1/2, and from that point we just algebraically simplify, and then we moved the negative exponent. Simplified that.